Hello and welcome back students to my channel. This video is in continuation with other videos. We are discussing questions which were asked on 31st of January 2023 JEE mains. So without wasting time, let us solve them one by one. Now question number 29. Which of the following correctly represents the variation of electric potential of a charged spherical conductor of radius r with radial distance r from the center? Now we know students that in case of a spherical conductor, okay, the charge always resides on the surface. Being a conductor, the charge will reside on the surface. So as far as the distribution of charge is concerned, it is just like a spherical shell. So inside, the potential is always equal to kq by r, where q is the total charge, r is the radius. Inside it is constant everywhere, same as that on the surface, whereas outside it will vary inversely as the distance. So the correct option is C option. You can see inside it is same till the surface, and outside it is a rectangular hyperbola. Moving on to the next question. The expression for an electric field is given by this: the electric flux through the cube of side when placed in, note the unit, okay, and given unit is in SI unit. So first we'll proceed in SI unit, and finally we'll try to convert this in volt CF. So as you can see, the electric lines of force are basically along x-axis only, that's all, because of this I can, you can see. Okay, so we have to consider the flux which is entering and the flux which is exiting. There is no flux through the remaining four faces, that is this face, the back side face, the front face, and the bottom face. No flux. Okay, all the four faces there is no flux. We have to calculate only the flux through this and this. Here you can see, here in the YZ plane x is 0. So since x is 0, electric field is 0 here. So no lines of force are entering. So here also flux is 0. That means we are left only with this surface. We have to calculate the flux to that surface. So flux will be, since lines of force are perpendicular to the surface, we can simply write it as B into A, because cos 0 will be 1. So, it is E into A, it is electric flux. So electric field is given as 4000 into x. Here x is, you can see, 20 cm everywhere. At any point here you can say x is 20 cm. So 20 cm means you have to convert it into meter. X square is there, so square it, volt per meter. Area is 20 into 20, that is 20 centimeter into 20 centimeter. So I have converted into meter. So everything is in volt meter in SI unit. So let us cancel out the things which can be cancelled here. So we have 1 0 gets cancelled here itself. Then we have 40 into 4 into 4. We have 4000 here. This is 2 upon 100, and this, 4 by 100, and this is also 4 by 100. So 3 zeros gets cancelled. We are left with 1 0 here. So we have 4 into 4 into 4 by 10 voltmeter, but the option is in, we have to find the answer in volt centimeter. So volt meter should be converted into centimeter. So we have 640 volt cm is the answer. Moving to the next question. Consider a group of positive charges. Which of the following statements is correct? Now, if we have a group of positive charges, if we have a group of positive charges here, then sorry, potential at any point due to each charge will be positive. So the overall effect of all the positive charges will be a positive potential. If you move to infinity, it will be zero. That's all. So potential can never be negative. Okay. So potential can never be negative. So net potential cannot be zero at any point. Of course, we are not considering infinity here. So your net potential of the system cannot be zero at any point, but electric field can be zero, of course, students, because probably the electric field is a vector quantity, and it is possible to choose a point where electric field intensity gets cancelled because of the charges on either side of the point. So it's quite possible. Okay. So the correct option is this. Net potential cannot be zero because potential has to be positive at any point because only positive charges are there. However, electric field being a negative vector quantity, it is possible to have a zero electric field. C option is the correct answer. Moving to the next question. Two parallel plate capacitors C1 and C2 each having capacitance this much are individually charged by 100-volt DC source. Capacitor C1 is kept connected to the source and a dielectric slab is inserted between the plates. Capacitor C2 is disconnected from the source and then a dielectric slab is inserted in it. Afterwards, the capacitor C1 is also disconnected from the source and the two capacitors are finally connected in parallel combination with the plates common potential. So here you see in the beginning, let us say the capacitance was C0, okay, and DC source was connected. The voltage of the DC source was V0. So that will appear here, and dielectric slab was inserted. So the new capacitance will be K times C0, and the charge will be K C0 V0. This is a charge. Then coming to the next capacitor, the capacitance is K C0, but the charge remains only C0 V0 because it is clear. It was clearly given that the capacitor C2 is disconnected from the source and then the slab was introduced. So this I'll write it as Q2. So these are the final situations here. Okay. Now when they are connected in parallel, the total charge will be shared by them equally because they have equal capacitance. Remember students, the capacitance are equal. So the total charge will be shared equally by each of them. Okay. So if we want the common potential will be total charge upon C effective. So total charge is how much? K plus 1 into C0 V0. Effective capacitance is twice K C0 because they are in parallel. So finally we have K plus 1 by 2 V0 to K. This is the final answer. So just it's a matter of substitution. K is given as 10. So 10 plus 1 is 11 by 2 into 10 into V0 is 100 volt. You can see it's 100 volt. So 55 volt is the answer. They'll have a common potential of 55 volt. That's all students in this video. Thank you so much for watching.